Good morning, everyone, and welcome to today's Jeeps Media Group webinar with Custom Concrete Specialists, also known as CCS Group. Today, we'll learn how inspection technology is transforming the grain industry by improving both safety and operational efficiency. This webinar will explore how tools such as interior and exterior drones and ground-penetrating radar are changing the way silo inspections are performed. We'll learn how these technologies can reduce the need for confined space entry, minimize risk to personnel, and provide accurate real-time data to support repair and maintenance planning. Our presenter today is Hayes Guillot. Hayes is a technology and inspection specialist with CCS Group. He holds a degree in precision agriculture with a specialization in unmanned aviation from Northwest Kansas Technical College, and is an FAA Part 107 licensed pilot. Hayes began his career in drone sales and training, providing specialized solutions for the geospatial, agricultural, and public safety industries. Today, he works closely with clients to understand their operations and develop practical inspection strategies that improve safety, limit downtime, and help identify potential structural concerns. Before we begin, I'd like to point out that questions for Hayes can be entered at any time during the webinar by typing in the question box in the upper right corner of the screen. We will address your questions after the presentation. And now I will turn it over to Hayes.
Thanks, Sam. Good morning, everybody. I'm Hayes Guillot. Like Sam said, I am an inspection and technology specialist with CCS Group. And today we're going to talk about inside the bin without the risk, the next era of grain inspections. So I'll start with a little overview of kind of what I'll be going through today. So most grain elevators and mills were built between the 1950s and 1960s with a life expectancy of 30 years. Now, most of these facilities have long been operating past that, and part of that is because of maintenance and keeping everything running as it should. So we're going to talk about some of those maintenance areas, some concerns of what you'll find around these facilities, different types of inspections, and the deliverables and reports we get from those inspections, and the repair recommendations, and then finally taking all of what I'll present on and what we call bridging the gap and explaining what that is here later in the slide. So the importance of maintenance and maintaining a facility is preventative versus emergency. And so some things to consider would be cost. Structural repairs may cost 10 times more than preventative maintenance per silo. And then also to go along with that, the downtime. Preventative maintenance has little to no downtime as opposed to full scope structural repairs, which could span multiple weeks, if not months, depending on the scope of that. Then safety concerns. Anytime you have concrete laminating from a silo, there is that concern of it falling, hitting vehicles, hitting people. And so to go along with that, you have the increase in recordable injuries and workers' compensation costs. So nobody wants that. And then a little note here, concrete deterioration rates. It starts very slow. You get some little cracking, some spalling. But then once that shell starts to crack and you introduce moisture, freeze thaw, the weathering conditions, it increases rapidly over time. So don't wait for an emergency. Deterioration occurs. It's a normal part of concrete, normal part of your facility. Normal wear and tear, it happens. Exposure to weather, especially, like I said, that freeze and thaw, where you get moisture and then in the winter it freezes, and then when you get a warmer day it thaws, and kind of that repetitive cycle kind of causes that damage in those small areas to expand quite quickly. Then you have structural deficiencies and failures. So sometimes you'll see that when these silos were initially constructed, engineering back in the 40s and 50s wasn't as streamlined, wasn't as up to date as what we have now with the technology and stuff we use now. So they had to just kind of go with what they had. So rebar and the way they built these wasn't always an exact science. Then you have operational changes. So when these silos were built in the 50s or 60s, the turn rate of these bins wasn't as much as what a lot of these facilities are doing now. With the increased size of legs and conveyors, we're able to fill and empty these bins a lot quicker. And because of that, a lot of people add these larger pieces of equipment on the outside without reinforcing the silos themselves. So that can also rapidly increase the deterioration rate of a silo. And along with that, if you're adding any truck or rail loadout spouts, cutting holes in the silo, that will also affect your structural integrity of those silos. So we like to approach it as a yearly checkup as opposed to an emergency room visit. So focus more on the yearly, just check up, make sure everything's still looking good, rather than the, oh my gosh, we have a major problem and we need to get this fixed right now. So establish a baseline health check for your facility. We'll come out, take a look at it, the entire facility, make notes of any areas of concern, any areas that we want to monitor. And it doesn't have to be something wrong with your facility. I have a lot of facilities that just want that baseline health check and that kind of stamp of approval that everything looks good. That would decrease insurance costs. A lot of insurance companies, if you can show that you've had an inspection, it will decrease what you're paying for your facility's insurance. So being preventative or proactive as opposed to having to be reactive when there's something major happening. And then information gathered can be shared with engineering. So we share all of our deliverables with the customer, which then can be passed along to engineering companies and then just internally within the company or whoever else would need that. So I've talked a little bit about moisture freeze thaw, moisture migration. So moisture migration exerts force on concrete. It causes tiny cracks in that concrete. So when water gets in, freezes, it fills those new cracks. And then as that process repeats and kind of expands those cracks, water expands 9 times by volume during that freezing process. So even the littlest crack, if water can get in there and it freezes, it starts pushing that out, expanding cracks, corroding rebar, which when you introduce moisture to rebar, corrosion makes that bar expand as well, all the corrosion, which then causes more cracks and the lamination of concrete. So some external inspection areas I wanted to touch on today are the silo walls themselves. The apex walls are the kind of crooks of the round silos. The roofs, the beam pockets, cornice areas, and then any bulging areas and wall penetrating equipment, and then just all around noticeable changes or noticeable things around your facility. So your apex walls here are these areas here where the round silos tie in to the walls. A lot of times you'll see some separation here, so we just want to make sure that we're not seeing that, or if we are, we can monitor that as well. Then your roofs, so we're just looking at the roof coating, any pieces of equipment or such as spouts and fans that go into the roofs, make sure those are sealed and that you're not getting any moisture there. And then here up on the right side of the screen, any standing water you have sitting on your roof can eventually find some areas to penetrate into the bend. So we want to just take note of those. Beam pocket areas. So where your roof sits on top of the silo with those beams. They're two separate pieces. So your silo itself and your roof, it freely moves. So as those silos go into tension when it's filled or contract as you empty, those walls and those beams can knock up against each other. And so over time, that knocking up against each other can start causing concrete to crack out, the laminate fall, and then eventually those beam seats, you don't have any concrete holding those beam seats on. And in worst case scenarios, those beams will separate from the roof and potentially fall into your silo, causing quite a bit of damage and just very difficult to get out. So you definitely want to catch that before something like that were to happen. Then your cornices crack and fall off over time, especially as you have moisture running over them. Any cracks that moisture can find starts causing that to delaminate. Then any bulging areas, this area here would be a pretty big concern. We would definitely want to do something about that. There's a lot of pressure pushing up against these walls. I would assume just visually that this is lacking rebar, and we could actually find that out for sure by using a GPR or ground penetrating radar scan over this area, which I'll get into a little bit more detail here in a minute. But this is definitely an area that a potential rupture could happen. Then we definitely want to look at any wall penetrating equipment. So any of your aeration, any spouts, any fans. Sometimes when they put these in, they're an afterthought. So they'll just cut a hole and run air, like this here is aeration, run the aeration in without necessarily reinforcing that area. So if that's the case, you'll start kind of seeing some cracking and spalling around there. And then just any areas of, I call it noticeable changes, but any areas that we want to monitor over time to make sure that they don't get worse. So this area here is kind of a good example. Above and below, you're not seeing a lot of cracking, but this elevation here, you have quite a bit of vertical and horizontal and even some diagonal cracking. So we would want to take note of that and measure some of these areas, and then maybe a year down the road when we come back, just make sure that this hasn't grown. If it hasn't, then we know it's cracked to the extent of what it's going to do. If it has, then we can talk about why it's doing that. So this here could potentially be lacking rebar. It could be that the rebar is there, but it was floated too far to the outside of the wall in this elevation. So that's why it's starting to crack out as that silo goes into tension. It's putting some force on those outside walls and just causing some cracking. So there's a lot of ways we can determine what the cause of it is, but just here we're looking at it visually at this point and just want to monitor it. So then some of the technology we use for external inspections are this here is a ground penetrating radar, and I'll go into that a little bit here in a minute. And then sound testing. So what sound testing is we go up in a boom lift or up on some platforms, depending what elevation we need to sound test. And we'll hit the wall with a hammer to kind of determine if the amount of potential spalling in a certain area. Solid concrete will produce a ringing sound when hit with a hammer, whereas an area that has a risk of spalling will produce kind of a flat or hollow sound. So we'll go around all the way up the silo and hit some areas to determine which areas are at risk of spalling. We also use external drones to just get a very close-up look of the entire outside of the silo, the roof, the equipment running along the roof. So this here is a good example of one of those beam pocket areas that I was talking about a little bit earlier. So there's a beam behind here that as this silo goes into tension and then as it's emptied, that roof kind of moves and is hitting against the top of this wall and knocking concrete out. So we can get a really close look with the drone, and we capture videos for the entirety of the facility. We also capture up close pictures or points of interest, POIs. We can get elevations off of the drone. So it's constantly capturing at what elevation we are at. So I can say at 65 feet, there is a vertical crack on the west wall. And then all this data is very easy to share. We share in multiple different ways. So usually Dropbox, SharePoint, or we can actually send it to you on a thumb drive or a hard drive. And then this makes it very easy to re-inspect the same silo, same facility year over year. So we'll do that initial inspection, and then let's say a year down the road, we come back, we fly the exact same area, and we can compare and contrast any changes over that past year. So GPR, or ground penetrating radar, is this device here, and it helps locate horizontal and vertical rebar. So we are able to identify every single piece of rebar in that silo. We're also able to determine the depth of the rebar into the concrete and the entire wall thickness as well. One thing that I get asked a lot prior to doing the GPR inspection is, do the silos need to be empty, or can they be full? Can we be filling them, emptying them? The answer is yes. It can be full, it could be empty. This is an external inspection, and the way we do this is we utilize a aerial lift, and we start at the very base of the silo, and we run the scanner vertically all the way up to the top of the silo just underneath the cornice. And we are mapping every single piece of rebar along the way. And this is what it looks like on the scanner, as well as when I bring it into the software to process. These mountain ridges looking areas are the rebar itself. They're called hyperbolas, or we call them heartbeats, the little heartbeats as we go up. And this will show the depth into the concrete as well as the spacing between each bar. And I go in and I literally click on each one of these hyperbolas, and then it generates a report with all of the findings. So I'll show some reports here in a minute. The internal inspection areas, this is where we use that internal drone. So we put this internal drone in from either a top opening or a side opening, and we are able to inspect the entirety of the inside of the silo. So everything from the roof to the walls to the hopper, and just get a full look at everything going on inside that silo. So I wanted to show real quick the software. So I'm going to switch screens real quick. All right, so what I have here is the actual inspector software that we bring all the internal drone data into to process and look at everything. So we have a few different features here. One of the most interesting ones is this LiDAR point cloud here. So the drone itself, the drone we use is a Flyability Helios 3. And so it has a LiDAR puck on it, and we're able to create a 3D model of the entirety of the silo. So I'm going to kind of navigate around. You can see the hopper here. This lower entrance is where I entered the drone. It actually shows all of my flight path as I flew around the silo. And then if I zoom out here, zoom in a little bit, you can actually even see the roof beams and the wooden trusses. But what was going on with this silo particularly was they were having wood laminate off the roof. So if I go here, you can actually see where that wood was sagging and had fallen. And then if I go to the actual drone's camera, you can see that area as well. So this is a video which I had paused at this area to show the LiDAR in that area. But if I play the video a little bit, you can see me flying around, looking at the roof here, looking at some of those areas that were falling down. And you can actually, while this is playing, you can see the little model drone flying around as well. So I can actually at any point pause this video and say, okay, well, there it is in the video, and kind of look around in the model as well to kind of helps get your bearings. It also helps with just identifying areas. Then this is how we generate reports that we give over to the customers as well. So for every area that we need to take pictures of, or some concerned areas like this area here, we can take a picture, label it with like a criticality level. So definitely this is of concern. So we say very critical, and then I give a description. This will show all the elevation, the XYZ data, so you know exactly where in the silo this was taken. So if we took a picture of, I think I have some down here. So like a wall, it's really hard to see in the picture, well, like where in the silo is that? So we know that if I click on it, go into an edit, it shows the X, Y, and Z, and it will actually show in the video at what heading I was on looking at that. So 266, so we were kind of on a western side of the silo. So that's the software. So we can look at the entirety of the silo, like I said. So we're looking at the roof beams, we're looking at the beam connection or beam seats, which are where they connect to the wall, trusses or any supports, any cross arms, the decking, then the hopper, connection points, internal walls, and then if there's any foreign debris or commodity buildup, we can look at that as well. We can do volume of how much commodities in there. And then the drone itself also has thermal imaging. So the thermal imaging is really cool. We've actually done some flights into bins that were smoldering, that were on fire at one point, and they were trying to identify where those hot spots are and how much of it was still kind of smoldering. So that thermal camera sure helps with that. Like I mentioned, there is LiDAR. We're able to create that 3D model. We're able to take measurements off of that 3D model as well and send that to an engineer. Let's say they wanted to know the spacing between beams, how many beams were in there. We can give them all that information. So then we'll go back into the inspection reporting. So internal drone reports. So what is created out of that software I was just showing is a PDF report that has the points of interest, the elevation of where those were found, the location of issues, so on the northwest wall or the ceiling, where that is. Then you also have the LiDAR modeling. So you have a LiDAR model and thermal. And then we also send all of the raw data as well. So all the raw videos, the thermal data, the LAS file, which is that point cloud file. So if you have a software that's able to view that, and there's a lot of free ones out there that are free downloads, you can just download that, throw that file in there, and take a look at that 3D model. So I'm going to pull one of those up as well. Okay, so this is what that report would look like. It would be your town, the silo number. Then we would have kind of the name again, so your town, when it was created, any description, the number of inspections. So this one was just one inspection, but if we had multiple, it would have 4 inspections. And then the silo number of points of interest, so 20. Then those criticality levels and how many of those points of interest fall into each category. And then the total flight duration. So this inspection lasted 25 minutes, and that was with 4 flights. So 4 flights took totaling 25 minutes of flying. It shows each individual flight and how long each of those flights were. And then it has a little flight icons glossary. So what kind of flight was this? A mapping flight. We used LiDAR, thermal. There is a utility thickness payload that's an optional payload, and then a gas detection payload as well. Currently, we're not utilizing either of these, but those are easy add-ons that we could definitely throw on there. And so these are, again, each of the flight, a little short description, stuff to do with the actual drone model we used, a little, basically like a little picture to show each one. And then if you get down to the meat and the potatoes, those criticality levels, but then you get to the actual points of interest. So this was a silo number 105. It shows this area of wood falling down. It was very critical. The sensor distance, so it does have a distance sensor. And so it says we were 129.9 inches away from the roof. Our pitch angle, so the camera's pitch angle, and then our heading of the drone itself. So how far up was that camera tilted? Then your X, Y, and Z. So we were 106.17 feet up. The distance away from me, so where the controller was 106.92. And then the XY data, and then a comment. So a large area of roof decking has been separated and is at risk of falling. So you have a lot of these different angles. I got closer. So just anything that is of concern or needs to be monitored or even in good condition. So if we look at some areas of like the beam pocket areas, and we just note that beam pockets are in good condition, well, great. We can just monitor all of those. So I'll go back to my slides here. So GPR, so this is what that GPR report, once I get it out of that software, looks like. So this is just a short snippet of a full report. This silo actually had multiple mats of rebar, 2 mats of rebar actually, and this is the outer mat of the rebar. This was the elevation that the first bar was found at, and then its distance to the next bar. Also, if you have original engineer drawings and are able to provide those, we can compare the designed spacing to what was actually found or where the bar was actually placed. And then the rebar depth for this particular silo, it's very thick walled, multiple mats of rebar, so the rebar depth was very good. You have a few areas here where it fell out of the design spacing. So for any of those, it's going to be highlighted red to show that it fell out of that spacing. Lastly, this is just another way of viewing the same data, and it shows the same information, the spacing, and then those elevations in feet, and then the rebar spacing versus rebar depth. And so with all of this information that we're gathering, so if we do find something that needs repaired, we are able to come back, identify, and go through all of the data collected and provide very accurate repair recommendations because we were able to capture so much data. So this is just an example of what a shotcrete liner agreement would look like. So you have the typical scope of work, mumbo jumbo. Then you'll get into the meat and potatoes of the actual scope of work. So this one here was a shotcrete liner of silo number whatever. It will be 100-foot tall and whatever diameter so that silo is. You'll have kind of the breakdown of order of operations. So, project mobilization setup, safety orientation, setup flagging, and then we'll get into the actual materials we use, our actual methodology, how we're going to approach the repairs. We're going to install 6-inch number 4 steel rebar pins, so all of that. So we have scope of work, shop drawings, any materials we'll use, we'll have material data sheets, the project schedule, so how long is the project going to take, and then any safety data sheets will be sent your way as well, then any references, and then obviously project pricing. These are all the types of repairs that we currently offer. So we were just talking about shotcrete liners, concrete crack and spall repair. That's this exterior cracking repair. For any areas that need to be chipped out, we'll right angle cut and we'll put a rust inhibitor on the bar and clean up the rebar. We do hopper repairs, hopper installations, beam pocket repair, roof cap repairs and replacements, roof and wall coatings, and then carbon fiber structural reinforcement. So that will be around the beam pocket areas is where we use carbon fiber to hold that beam in place, but also give it some ability to move back and forth as it needs to do. Cornice repair, and then any rupture or explosion repair, any emergency repairs, we do that as well. Then steel bin foundation repair, steel bin coatings, and manway installations. So lastly, taking all of this, what we just talked about, the idea is to go from the customer saying, I have an issue, and bridging the gap to the delivering stamped engineer drawings. So being able to provide engineers with this data, provide the customer with this data so that we have a full picture of going from I have an issue to here's the repair, here's the solution, and making sure that we have a quicker construction start, completion date, have clear expectations from the customer, from the engineer as to what we will be providing. And this saves time, this saves money, and it's an overall safer project. Lastly, this is my contact information. So with any questions after the webinar, I know we're going to have a question portion here, and I'll be able to answer a lot of those. But any of the ones that you think of after the fact, this is my contact information. So thank you for your time, and we'll open it up to questions.
Thanks, Hayes. Let's move into the Q&A. If you have a question, you can enter it in the box in the upper right corner of your screen. Okay, Hayes, I'm going to start with a question. How often do facilities need to be inspected?
So like I kind of touched on in the webinar, we recommend a initial inspection, and then usually once a year is a good time frame to just go back, reevaluate, maybe just only looking at the areas that were of concern, or if there are no issues, just ensuring that nothing's changed year over year.
Can the inspection be performed while the facility is still running?
So it depends the inspection. So like I talked about with the GPR, being that that's a external inspection that can be done full, empty. Now, when you're talking about like an internal drone inspection, we ideally would want that to be empty and clean-ish. I know it's not always possible to completely clean your bin. And there are times if your area of concern for the internal drone inspection was purely that under the roof, the wood falling down, then it doesn't necessarily have to be empty because we're focusing on that area. But the emptier, the better for sure.
Do you offer inspections related to food safety, for example, mold, pests, etc.?
That's something that we have talked about. It's not something I've currently done personally. I believe before my time here we might have, but that's a great question, and I'd love to talk to you more about kind of what specifically you'd be looking for.
What preparations does a facility need to make before an internal drone inspection?
Yeah, so internal drone inspection, the biggest thing is how full is the bin? What kind of commodity is in there? There's some types of grain that produce more dust when I'm flying over it with the drone. So with those, I usually ask that the grain's lower if it can't be emptied. The grain's lower than at least 20 feet off of what I'd be flying, so I'm not kicking up a bunch of dust and makes it very difficult to see. And then the opening sizes and entry points for the drone, we typically, that Helios 3 we use, I need a 20 inch by 20 inch hole. Traditionally, that's the hole up top. Now, there are some silo designs that have larger openings in the bottom as well. But as long as we have a 20 inch by 20 inch, I can get that one in. But we also have a smaller internal drone that can fit into like a 15-inch hole. So those are the main things. And then just having the grates removed if there's grates up top, the area kind of around where we'll be going in somewhat clean. And yeah, just someone there.
How accurate is GPR compared to destructive testing?
So with GPR, the big pro is that we're not having to chip out an area to look at anything, and you're getting the exact depth and the exact amount of rebar. Now, when you would do destructive testing, this is the one thing that GPR can't identify is the size of the rebar, what number rebar was used. So that would be one time where destructive testing would be used if we have to identify the size of the rebar used.
And when would you recommend GPR instead of a visual inspection?
Usually the visual inspection, so as we walk around and we notice any areas like that one area I showed of bulging, I would definitely recommend a GPR there to see how much rebar is lacking, how much is missing there. And so that can definitely give us a percentage of structural, like missing structural integrity. So we can say it's missing 50% of the rebar that should have in it or whatnot.
How quickly does the customer receive the reports?
So usually it's within a week of my inspection. So let's say I went out today on a Tuesday, I usually will have that back over to you, all the deliverables, and then a kind of a follow-up email trying to schedule a time to get together to look at everything no later than the following Tuesday.
And I have one last question here. If a facility has never been inspected, where should they start?
Start with that all around inspection with like a site walk, external drone, and then with that site walk, we can talk about okay, we would recommend some GPR or an internal drone based on that. Also, any pictures that customers have that you have to send us before we come out always gives us a good idea of kind of what we're walking into and, a specific area we need to be looking at.
That's going to wrap up our Q&A. Everybody who registered for today's webinar will receive an email with a link to the recording. A big thank you to you, Hayes and CCS Group for sharing their time and expertise with us today. And thank you all for joining the Jeeps Media Group webinar. Have a great rest of your day.